before the final. Okay, just remind you. Okay, so now we are in the chapter 10, C pointers. Okay. Use full screen. So pointers actually is a very special operator, and so when we use point, so our code will become more powerful, and but when we use pointers, so also should be very careful, because when we use pointer, then we can operate. Actually, this means write and read memory directly. The dangerous thing is for write something into the memory by using pointers. Yeah, so this is a little bit dangerous. So you should be careful. Okay. But point, yeah, is the most powerful feature of the C language. Okay, so pointers enable programs to simulate pass by reference, to pass function between functions, and also to create and manipulate dynamic data structures. So that such as data structures that can grow and shrink at execution time. Okay, such as linked list, CRUD, stack, and trees. Okay. So this makes the C language more powerful. Okay. So pointers are variables whose values are memory addresses. So this means here we can operate memory directly through pointers. Yeah. So normally a variable directly contains a special value. A point, on the other hand, contains address. So address of a variable that contains a specific value. Okay, so now we need to go to these figures. So referencing a value through a pointer, so it's called indirection. So this is the normal way we define the variable, right? So variable name is count, and the variable value is 7. So the name count so directly reference a variable that contains the value 7. Then if we define a point, so the point name is counter point, so PTR for point. Then this point so will point to the variable count. So this means the point counter indirectly reference a variable that contains the value 7. So counter point actually is the memory address of the counter. Okay, so declaring pointers. So pointers, like all variables, must be defined before they can be used. So this is the definition. So int star counter point, then count. So star counter, so this define a point to a integer variable. So this is usually we call this is an integer point. Then counter, so just the normal integer variable. Okay. So usually we talk like this, yeah. So counter point is a point to integer int, or counter point points to an object of the type int. So counter point to an integer, just like this. So star, this one, so apply only to the counter in the definition. So star with the variable name. So this this variable is a pointer. Okay. It's here. When star is used in this manner in a definition, it indicates that the variable being defined is a pointer. Okay. So point can be defined to point to objects of any type. So this means we rendered variable type before. So an integer, float, and double like string. String is an array, right? So we said before, array name is a memory address. So actually, array name is just a point. Okay. Okay, so initializing and assigning value to pointers. So point is value is memory address. So this means assign value to a pointer. We will assign a variable's memory address to a pointer. So point should be initialized when they are defined or they can be assigned a value. A point, this is why it's important, okay? So a point may be initialized to null, 0, or an address. 0 is just the 0. Null so means nothing. So this means the point doesn't point to any variable. Address, so just the memory address. Okay. So null means nothing. Okay. So null is a symbolic constant defined in the standard definition. So this is std for standard, we said before, df for definition, .h, header file. This one, okay. This one actually is already in the standard IO, this library. Initialize a point to 0 is equivalent to initializing a point to null, but usually we use null, so null is preferred. So when 0 is assigned, so it first converted to a point of the approximate type. The value 0 is the only integer values that can be assigned directly to a pointer variable. So we will talk about this later. So point actually its value is in the hexadecimal number. Okay, so now we use this for the scanf function, right? So this one ampersand simple or address operator actually is a unary operator that returns the address of its operand. Okay, so just like this. So int y equals 5. So this is the normal variable. Then int star y point. So this define a point to an integer variable, right? Then we can use this assignment. So y point equals ampersand operator y. So this one, so we'll get the variable y's address, memory address. Then is assigned to y point. So this one, so assigned address of the variable y to the point variable y point. So now we can say variable y point is then set to point to y. So let's go to this one. So this figure. So y integer has value 5, right? Then we just assigned y variable y's memory address to y point. So now y point, this point now point to variable y. So it's this one. Yeah. Then the next one, so figure 7.3, so this one. So this is the variable y, start from here. Its value is 5. Then is the memory address, just for example, this is 600,000. Then for y point, then its value, so it's just this memory address, 600,000. Since y point is also a variable, right, just a special variable, it has its own memory address. Then its own memory address is this 500,000. Okay, so let me think. Okay, so the operand of the addressed operator must be a variable. So that means this one ampersand simple. Oh no, I missed this simple. This one. This is the addressed operator. Then the address operator cannot be applied to constant or expression. Okay, so in direction operator star, the unary star operator, commonly referenced to as the in direction operator or the dereferencing operator, so returns the value of the object to which is operand points. Okay, so this is seems complicated. So actually like this. So this is the point. If you use the star in the front of the point, so then this will get the value, this point 2. Okay, so now for this one, so print f %d star y point. Since y point is pointing to the variable y. Variable y has the value 5, right? So star y point. So then we will get the value, the point points to. So this means for here, so we will get the 5, the value of the variable y. So using star in this manner is called dereferencing a point. So dereferencing point that has not been properly initialized or that has not been assigned to point to a special location in memory, so it's error. So this of course right straight, because when you use this one, so the point so should point to a variable. So otherwise we cannot get that variable's value, right? Okay, so before we use this one star operator, just make sure the point has pointed to a variable. Okay. So this is an example. Okay, so let's go to example. Let me check. Yeah, example. Okay, I have to edit this. Okay, so for this one, so standard input and output head file, library head file, right? So main body. So now we define a integer variable a, and its value is the 7. Then define a integer pointer. So int star a point. So this means this is integer point, or this point will point to an integer variable. Then equals ampersand a. So this means ampersand a, we said before, this will get the variable a's memory address, then assigned to point, a point. So now after this statement, so a point is point to variable a, right? And also a point is just the memory address of the variable a. Then printf, the address of the a is %p. So %p, this is for point. So this is for point. Then this is the first one. So ampersand a. Ampersand a, so get the variable a's memory address, right? Then the last one, so the value of the a point is %p still point, so also is a point. So we said before, a point now is point to the variable a. So a point's value is just the variable a's the memory address, right? So this means these two variables should be the same. Then the second printf, the value of the a is %d, so just get the value out here. Then the value of the star a point is, so star a point, so just get the value the point points to, right? So also should be 7. Okay, so printf showing that star and ampersand are complements of each other. So now this seems a little bit complicated, so let's show this. Okay. So first operator, this is star a point. Star a point, so get the variable a, right? Because a point points to variable a. So star variable a, no, star a point, so get the variable a. Then ampersand symbol, so this will get the variable a's memory address. So for this command, so actually this point, so it's the memory a's address. So actually should be the same as these two numbers. Then the last one, so here a point is a point, ampersand, this one, ampersand a point, so this get the a point, the memory address. Then star, this one, so get the memory address that point to the value, so get that one. Okay. So this, yeah, I think make this hard to understand. Okay. So a point, just remember a point value is the memory address. Okay. So then ampersand symbol, so this is get the memory address, variables memory address. Then star, so get the value in this the memory address. So this actually back to the a point. Okay, so let me just run this one. So you will get the same 4 numbers. So variable of the A is 0x, x, this is for the hexadecimal number. So hexadecimal number, I think we talked about this before. So it's actually is from the number 0 to 9, then A, B, C, D, E, F. So totally 16 numbers. Okay. So you can see we have some letters, 7, F, F. So this one. Then the value of the A point, so it's the same number here. Okay, just remember X, so means a hex number. The value of the A is 7. Then the value of the star A point is also the 7, because this point is point to variable A. Then showing that star and ampersand operator are the complements of each other. So these two get the same address, just the same number, so just the memory address of the variable A. Okay, so just go here. Okay, so this one just the order of the operators. So the new one is we get here, star and ampersand. Okay, so they are in the second. So passing arguments to functions by reference. So we said before, passing arguments to functions so has the two types: pass by value and pass by reference. Pass by value, this is the default method. Right? So just send a copy to function, a copy of the variable to function. Then passing by reference, when we pass array to a function, so we use this method. So actually, I just said before, array's name, so it's just a point. So it's a memory address. So this is the reason this is in the pass by reference. So all arguments in C are passed by value in default. This is in default. Okay. So many functions require the capability to modify variables in the caller, or to pass a point to a large data object to avoid the overheads of passing the objects by value. So this will, if a large data object if passed by value, so you will make another copy in the memory. Right? So this is usually use a lot of the memory. Okay, so in C, so you can use points and also indirection operators to simulate pass by reference. But as I said before, passed by reference. So this means you can change the original value in functions. This is because passed by reference, we just write the memory directly. This is powerful, also instantaneous. So when calling a function with arguments that should be modified, then the addresses of the arguments are passed. So let's use the point. This is normally accomplished by applying the address operator ampersand this symbol to the variable in the corner, whose value will be modified. So in chapter 6, I just wrote this: arrays are not passed using the operator this ampersand symbol, because C automatically passes the starting location in the memory of the array. The name of the array is equivalent to the ampersand array name 0. So array name is just a point. So it's a point to the first element in this array. So when the address of a variable is passed to a function, the in direction operator star may be used in the function to modify the value at that location in the corners. So pass by value. So this means we will compare these two. Okay. So this program 7.67.7 so process two versions of two of functions. Let cubes integer, cube by value, and cube by reference. So the first one, 7.6, passes the variable name by value to the function cube by value. Then this function cube by value, so cube is argument and passes the new value back to the main, use a return statement. Then the new value is assigned to number in the main function. Okay. So this one. Okay, so the same standard input-output library. So define this function. Okay, so int cube by value. So just one input. int n, right? So don't forget semicolon at the end for function prototype. Then int main void. So int number equals 5. So define an integer variable. Name 5, value, name number, value 5. Then printf, the original value of the number is %d number. So just the print out, so should get 5. Then the last one, call this function. So number equals cube by value. Then input argument is just the number. So send a copy of the number to this function. Right. Then printf, the new value of the number is %d \n number. So in this calling, so call this function, and then the function return value is assigned back to the number. Okay, so in the cube function, so int cube by value, so argument is the n. So return is very simple, so just return n star n star n. So n times n times n. So cube of n. So return this. Then back here, so then the number, so now here should be cube of the number. So run this. So the original value number is 5. After cube, so the new value of the number is the 125. 5 to 3, 5 power to the 3 is 1. So this is the default method, right? Just passed by value. Okay. Passed by value. Actually here, n variable, local variable n in the cube by value function is a copy of the variable number. So just a copy of the variable, original one. Okay, so this one, okay, passed by reference. Here So now this will change. So now this is passed by reference. So void, so no output, right? No return value. So cube by reference. Then int star endpoint. So this means here this is just a point. So the argument here is an integer point, or is a point points to an integer value. Int main void. So int number equals 5, the same as before. Then printf, the original variable of the number is %d number, so should be 5. Then for here, cube by reference. So you can see here the argument, so should be a point here. So ampersand number, so we said before, get the memory address of the variable number. Then pass, so it's the memory address, then pass into the function. Then printf, the new value of the number is %d \n number. So just get the new value. So go to the function. So void again, so no output, no return values. Cube by reference. So int star endpoint support here. Then, so this seems a little bit complicated. So first let's go to right side. Star endpoint. So n point. So actually this is point to the number, right? When here ampersand number. So this one get the number's memory address. Memory address now is assigned to the local variable endpoint. So endpoint value is the memory address of the number. Then here star endpoint. So this one will get the value the point points to. So star endpoint. So this get the number 5. Then times star and number times star and number, so it's cube. Then after this operation, so the new value, so now is assigned back to this value, actually to this variable, the star endpoint. Okay, so this means actually for here in this function, we operate the original number, this variable number directly in the memory. Okay. So read this value, then get cube, then assigned back to this variable. Okay. So use the point. So this again. So the original value of the number is 5. Then the new variable, the new value of the number, so is the 125. Here, so you need to understand actually star and this one, the ampersand operator. So these two also operate. These two operators. So and this ampersand simple the operator. So get the memory address of a variable. Then star a point. So this operator. So get the value the point points to. Okay. Okay, so for this one, so function cube by reference, so takes as a parameter a point to an integer. called endpoint. The function, so D references the point and cube the value to which endpoint points, then assigns the result back to the star endpoint. So this is just the number, really the number in main function. So does change the value of the n number in the main. Okay, so a function receiving address as an argument, so must define a point parameter to receive the address. So here we define this int star endpoint. So this means this variable is a point, right? Point to integer. So the head specifies that cube by reference receives the address of an integer variable as an argument, stores the argument locally in endpoint, this point, and does not return by word. Okay, so the function prototype for cube by reference contains int star in parentheses. So len include for documentation and purpose are ignored by C compiler. So this means actually this one, just like we said before, for function prototype, we don't need to type in the variable name. We just need the variable type. So for example, if I delete the name, the int star, so this means this argument is a point. So this is also right. So you can see no error show here, right? You can compile, then get the same result. So in the function prototype, again, the arguments type are important. Arguments name are not necessary. Okay, so for a function that expects a one-dimensional array as an argument, then the function's prototype and head can use the point notation shown in the parameter list of the function cube by reference. Okay, so the compiler does not differentiate between a function that receives a point and one that receives a one-dimensional array. It's because one-dimensional array, the name said before, is just a point. This, of course, means that the function must know when it is receiving an array or simply a single variable for each it is to perform pass by reference. So actually, we did this, okay. When the compiler encounters a function parameter for a one-dimensional array, so of the form int b then square brackets, so then the function knows this is for a array. The compiler converts parameter to the point notation int star b. Okay, so actually this is the same, because the point is just a memory address for array. So b is just the memory address of the first element. So you could define by this format or this format. So both works. Both work. So use pass by value to pass arguments to a function unless the caller explicitly requires the call function to modify the value of the argument variable in the caller environment. So pass by value. So this prevents accidental modification of the caller arguments. And this is another example of the principle of the least privilege. So this means usually when you write the C code, so if you could use pass by value, just pass by value. If the function need to change the variable, original variable in the main function, so you have to use the pass by reference. So pass by value. So this is for pass by value, grouped by value. So actually just send a copy of the number n to the local variable n, right? So here, just send a copy of the value. Then the local variable n has the value 5. Then decode. So this is keep going. So here. So now in the group by variable, so get the 125 return. Then in the main function, so return value, then assigned back to the number. So now the number is 125. Here number is 125. So passed by reference. So passed by reference. So for here we define a variable that has integer variable number, and then it has value 5, right? Then for the function here, this is a point, right? That point. So now doesn't have any value at the beginning. Then for this one, so now when we call this function, so ampersand this operator, address operator, so get the memory address of the number. Then this memory address then is assigned to this point. So assign this point. So this means n point now points to the number n. Then for this multiplication, so star n point. So star n point, so get the value the point points to. So actually it's the 5 here. So 5 times 5 times 5, so we get 125. Then 125 then is assigned back to this point, the variable point 2. So then 125, so go back to the number assigned back, put the number in this memory address, so 125. So now the number has the new value 125. Okay, so this is for the point. Okay, then constant. So constant for point, so now we have the many combinations for point. The constant qualifiers enables you to inform the compiler that the value of a particular variable should not be modified. So we use the constant before for the array, right? So if you define array is constant in a function, so in this function, so we cannot change elements value of the array. Just we can read, but cannot write. So now this because so for point or a variable. So here, so 6 possibility exists for using or not using constant with function parameters. 2 with the passed by value parameters passed, and 4 with the passed by reference parameter passed. So now we talk this one by one. Okay. Okay, so here if an attempt is made to modify a value that is declared constant, then this will get an error. Okay, so now 4 ways to pass a point to a function. A non-constant point to non-constant data, none to none. A constant point to non-constant data. A non-constant point to constant data. And a constant point to constant data. Okay, so a little bit confused, so let me talk about this. So the first one is the non-constant to non-constant. So this is like the normal. So non-constant point to non-constant data. So this means date and the point, both of them could be changed. So their value could be changed. So in this case, the date can be modified through the point, the dereference point. And also the point can be modified to point to other data items. Okay, so this means the point can be changed to another variable. Okay, so a declaration for a non-constant point to non-constant data, so does not include constant keyword. So this is like the way we did before. So such a point might be used to receive a string as an argument to a function that processes each character in the string. Okay, so this means we could modify the characters. Okay, so this is the new one. So 7.10. So now it's 7.10. Okay, so now we have the new library now. So first the standard input and output, right? Then include C type. So for this library, so it's okay. So C type this library. So it has the functions for operating strings. So here we need to use a new function here, to up. So this function is in C type library. To up, so just like its name. So convert each character to its corresponding uppercase letter. If the original character is not a letter or is already uppercase, so no change. So if the letter is in lowercase, then to up function will change the this lowercase letter to its corresponding uppercase letter. Okay, here. So this is the one. So void, so no output, right? No return value. Convert to uppercase. Char star s point. So this means this is a point to a string. Char is for string. Okay. So in the main function, so we define a string. So char string here equals, so small c, capital A, small a, capital R, then small a, capital C, small t, small e, small r, small s, and then $simple 32.98. So this means in this string, some letters are lowercase, right? Lowercase, and we also have the digits, also the simple. Then, so printf, the string before conversion is %s, this for string, array, correct array. So string. Then convert to uppercase. So here we just need the string name. So string we said before, this is just a specific type of the array, right? Then array name is just the memory address. So this is the point to the first element in this array. So we can use string name directly. Then printf, the string after conversion is %s, then \n new string. Okay. Then void convert, so this is the function. So convert to uppercase, then char star string. Okay. So this, and just remember here. So here we get the string memory address. Then this one is assigned to this point, right? S point. So S point now is point to the string. It's pointing to the string. Okay. Then while star S point is not equal to \n. So we know for the string, the last element should be this \0. This is the end terminator of a string. This is the last element in string, right? Then star s point. So this will get the point, the value the points to, right? So this will get the first at the beginning. So it's the first element of the string. Then star s point equals to up, then star s point. So again, so at the beginning, star s point is the first element of the string. So if this one is the lowercase, this character is lowercase. This letter, actually the letter is lowercase. Then after this function, so we will get the uppercase, then assigned back to this element, first element. Then plus s point. So this point, this because the string, the character just occupy 1 byte in the memory. So one character just use the 1 byte in the memory. So we can use the plus star. So just add s point by 1, added by 1. So then s point so will point to the last character. So now it's the second character. Then we'll do this again. So until reach the last element in the string. So then while loop starts. So for this function, so we look through all the character in the string, then convert to use the uppercase letter. Uppercase letter if the original letters are lowercase. Okay, run this. So the string before converting, so it's here. So we know the after converging, so small c go to capital C, capital H keeps the same, small a go to capital A, R keeps same, small a now is capital A, right? So just convert the lowercase letters to uppercase letters and also uppercase. Then simple and the numbers keeps the same as before. So just be careful here, plus S point, this is only for the string, because string just use the 1 point. No, sorry, 1 byte in the memory. If you use the array is the integer or other variable, other type of variable, so then if you want to move the pointer to the last element, so should you add it by other number. So just for example, if it is the integer array, for integer variable, use the 4 byte in the memory, then this one should be S point plus equal 4. So we need to add it by 4. Okay. Then this point would point to the last integer number in the array. Okay, so this is a non-constant to non-constant. Okay, so then the next step, a non-constant point to constant data. So this means point could be changed, but data is a constant, so it cannot change this value. So this one can be modified to add to other data items of the appropriated type, but the date to which this point cannot be modified. Okay. Point could point to other variable, but this variable is constant. Okay, so such a point might be used to receive an array argument to a function that will process each element without modifying the data. Okay, so this is the last one. Okay, so this one, so now the definition now is different. Void, no return value, print, characters. Then this one, so constant, char, star, S point. So this is a non-constant point to constant data. Okay, so let's show. Then int main function, so now define the string. Okay, define the string. So print characters of a string. So put the string is, then print character string. Okay, again string here, the string name is a point. Is the binary address of the first element. Then in the function, so let me check. Okay, so here this is defined as a constant. So void print characters, so constant char star as point. Then Now we use the for loop to do this. So for loop, first one, so no the left side, just the middle side, star s point is not equal to backslash 0 until the last point, right? So plus s point. So s point could change, right? So here, oops. So now the point could change. So move from the first element to the second, to the third, to the last, like this. Then print f %c just for one character, c for child. Then star point. Okay. So let me check this one. Okay, yeah. Okay, so this, just want to check whether we have the space on no space here. So for this one, so you can see here, constant char star point. So point could change, but for this string, the original string now is constant. Okay, so this is protected by this constant keyword. So the string is, so that's the print out the original string, right? Print character of the string. So plus s point, so this means this point now is changing. So every time it's added by 1 until the last element. Okay. So for here, so s point, so is a point to a character constant. So because we define the constant here, so constant char star. So this is a non-constant point to constant data. So in the function, after each character is printed, pointer s point is incremented to point to the last character in the string. The point now is changed. Just the original character is constant. So s point cannot be used to modify the character to reach its points because this is a read-only point. So for example, let me use this one. So let me include one line here. So just for example, if I use this star point equals r, so should get a right error. Let me check. So you can see now this is an error, right? So we cannot change the original string value. Oh, no. So this is correct. So I use this. Let me check. Okay, still error. Error is here. So the read-only variable is not assignable. So this is a constant here. So we cannot change its value. So this statement is not correct. Okay, so So this one, let me check. This is 11. Yeah, this is 11. So 7.12. So it should illustrate the attempt to compare a function that receive a non-constant point to constant data. Then this function attempts to modify the data pointed by the x star. So each result in a comparison error. Actually, we did this. Okay, so this very simple. So let me open it. Okay, so already show error now. Okay. So for this one, so void f constant int star x point. So x point is a non-constant point to constant data, right? So then for here, so int y equals 5 f ampersand y. So now point x point now is point to variable y, right? But y now is constant. So void in this function, so we try to change its value. Star x point equals 100. So this is not correct because now this point to a constant data, cannot change. So we get an error here. So the same error we did last example. Okay, so keep going, the next one. So if memory is low and the execution efficiency is constant, so use port. So we look at use less memory but faster speed. If memory is in abundance and the efficiency is not a major concern, then pass data by value to enforce the principle of the least value. Okay, so now this third one. So a constant point to a non-constant data. So this means point is constant. You cannot change this point to other variable. But the point, the value, the variable, the point points to could be changed because data is non-constant. So always points to the same memory location. So we cannot change the point value. The date at that location can be modified through the point. So this is the default for array name. So an array name is a constant point to the beginning of the array. All the data in the array can be accessed and can be changed by using the array name and the array index. A constant point to non-constant data can be used to receive an array as an argument to a function that assigns array element with only array index location. So that's the index number. So points that are declared constant, so must be initialized when they are defined. So if the point is a function parameter, then it is initialized with a point that passed to the function. So then the next one, example, figure 7.13 attempts to modify a constant point. So look at her error. The point is defined to be type of int star constant. So this is star constant. So point is constant. So point is a constant point to an integer. Then the point is initialized when the address of the integer variable is. Then the program attempts to assign the address of the y to point. Point is constant, so this assignment should not be correct. So we should get error. So constant point to non-constant data. So now we define two integers here, int x, int y. So now for the x, so for here int star constant p, this is point, so equals ampersand x. So assign x memory address to the constant point, right? So point is constant, but date is not constant. So we can change the data. So we can 7 star point equals 7. So we change the data value. But the point cannot point to another variable. So point equals ampersand y. So this is error. Okay. We cannot change the point value. Point is constant. So just for example, so we can do more for this one. So we can actually do here. So we can change it to another value. This still is right. Oops, I typed the wrong one. Okay, so you can see no error here. So first assigned x to y, then assigned x to 10, right? So we can change the value that the point points to. But we cannot change the point to another value because point is constant. Okay, so this is the third one. Then the last one, so it's constant point to constant data. So point is constant, date is also constant. So both of them cannot be changed. Okay, so now constant. So first we define x equals 5. Y we didn't just define, we didn't assign any value. Then for constant to constant. So first constant int star, so this is a constant point, right? Then constant point here, so date is also constant, so equals ampersand x. So point is constant, date is also constant now. Okay, so printf back %d \n star point. So read the value from the point. This is okay, but change the value is not okay. It's not right. So star point equals 7. So this is error because this variable is read only variable. We cannot assign another value to here. Then this one we try to change the point value. Also point is constant. So we cannot change the point to another variable. So this is also is an add. So constant int star constant. So both are constant. Okay, so just stop here. Okay, so let's go to, we have the a lot, example 40. So let me go to homework. So, okay, yeah, so 4, 6, 7, 10, 11, 12, 13, and 14. Okay, so many examples. The homework question, let me double check whether we can do this one. So for this homework question, so standard, this one, standard input output, define the symbolic constant size, so 80. Then in this, the function, so return value is integer, so constant char star s1, constant char star s2, right? So constant, so this is the second one. Let's go back to Hangout. Yeah, this type. So constant, usually we have example here. Yeah, the same one. So constant char star is equal. So this is a non-constant point to constant date. Date is constant. Point can be changed. Then two string here. So we define two string, string 1, string 2. Then enter two strings, scanf percent 97, no sorry, 79 s percent 79 s, because this is the 80. For the string, last element should be \0. So at the most, so you get 79 characters. Okay. So string 1, 2. So get two strings from the keyboard. Then printf, the result is %d\n, so call this function, right? Mystery 3, string 1, string 2. So two strings inside this function. Okay, so int result equals 1, so 4, left side ignored, the middle one, star s1 is not equal to \n, the end of the string 1, and so double the ampersand send, this for AND function. Then star s2 not equal to \0, so this means only reach the end of the both string, then the for loop starts. Then plus s1 plus s2, comma, here for separation. Then if star s1 is not equal to star s2, return 0. I think now the s1, so just return result. So now you can know how to what's this function for. Right? So actually it's for this if function. So you need to type this in the compiler, okay, and then run this code and check what this function for, this code for. So what does this program do? Assume that the user enter two strings of the same names. Okay, so just this one. So let me post it. Okay. Okay, go to colors. So let's see. Okay, this is the assignment. One. Okay, so let me. Oh, I forgot to do that. Okay, so that's the Tuesday. Okay, go back to home.